Hello, innovators. Thank you for joining the opening session of the DigiTech conference sponsored by Beeline. Our theme this year, Innovating to Create Smarter, More Efficient Mining. The esteemed panel of experts will help us to understand how technology is transforming your industry. Are you ready to shape the future of Mining 4.0 in Kazakhstan? Please scan the QR code and take a few minutes to complete the survey. We'd love to get your feedback as we map out the digitally enhanced future of the mining industry in Kazakhstan. Your participation is completely voluntary, and your responses will be kept confidential. Thank you.
Ну что, доброе утро, уважаемые дамы и господа.
Well, good morning, dear ladies and gentlemen. Thank you so much for joining our panel session today. The name of our panel session is Innovations for Creating More Smart and Efficient Mining Industry 4.0. My name is Vyacheslav Kwan, and I am the head on Client Development Network. My name is Vyacheslav Kwan. Today with me there are my colleagues, and they are our speakers. Sergey Nazaryan, who is the Deputy General Director on Operational Efficiency, East Mining Company. Alexey Shmonov, he is the head of Geovia Solutions Implementation Department, Dassault Systems. Pavel Chensov, who is an expert on digital transformation, Step Change Global. Nikolai Polshin, the manager on sales support, Metso. Ekaterina Zakandekina, who is a managing partner, software. And we have Vipul Singh, who is co-founder and general director of Aero. In our panel session, we have provided for the survey. Now we will show you the QR code. We kindly ask you to scan the QR code and to answer the questions. And if we have time, we will speak about the results of this survey. Okay, let's wait for a while, maybe just 15 seconds. Also, in the application on the website of the conference, there is a button, and if there are any issues with QR code scanning, you can use the button over there. So we have quite intensive schedule and agenda, so let us now move to the first report. The first presentation is my presentation. I want to present you the new project that Beeline Kazakhstan implemented for the gold mining company. So now I'm waiting for my presentation to be shown. So, you can hear me well, right? As a client of our company, RG Gold. RG Gold is a gold mining company that is located in Akmola region, and the project consists of two pits, the north and south settlements, and we have the gold mining plant. So that to understand the idea of the project, I would like to explain you what is private LTE. Now you can see the footage that was taken about a week ago from the deposit site, and here you can see the antenna or the post or the mast, and we have the base station in the bottom, and at the top we have our equipment. This is like Wi-Fi access point, and the radius of this station is about kilometers, but when we speak about Wi-Fi equipment there, of course, we understand tens and thousands of meters could be covered. So what is private network? This private network is for enterprise to transfer data on the territory of the enterprise in this closed circuit. So from the architectural point of view and technical point of view, this is the way it looks. We have this antenna, and it is located along the perimeter of the deposit, and there is a data center where all data could be sent. And there is also the specific vehicles, mining vehicles, some dump trucks, excavators, and we need to manage these vehicles, and so data from these vehicles would go to the main center, and then we are also using the other supplier services here, Venka. So this is a full case, and Beeline is a supplier of network infrastructure, and Venka would do this dispatcherization work. So the aims and the goals of implementing this private network. Well, our task was to create this private network with high capacities and, of course, with protection from outside threats. It also was very important to provide the access to corporate resources and to ensure that the information safety policy has been fulfilled. It is important also to decrease the operational costs for maintenance of this communication infrastructure, and also to create network bases for the dispatching of all these mining vehicles and equipment. It was very important also to enable safety of the employees at this production facility, because the production is quite dangerous. There are lots of excavators, dump trucks that are moving all around, and there is a high risk that people might receive some traumas. And so we had this requirement set for us by our suppliers. And what we did, in fact, we did the pre-project survey, then we did all of the work, and right now we are performing our monitoring, maintenance, and in case if it is needed, we can respond and we can come to eliminate all the deficiencies and faults. And as this pit is changing its form, it is deeper now, it is broader now, and now we put 2 more additional equipment there, and this is also included in our service. We have made efficient radio planning because we understand that there are some specific roads and routes, and there is a settlement for in place, and for us it was very important to have them full and equal coverage of all the territory. So we selected the specific equipment, taking into account wind, snow, and some other load, taking into account the types of the soils that is in this area, so that to provide also the very good signal in this area. So the construction has been made taking into account the mining works for the nearest 5 years. So for the nearest 5 years, there is no need to amend and to change this communication infrastructure. Well, in some case, we would maybe move some of the equipment to some specific areas. So we've built such type of structures. At the bottom, there is a container with the equipment of our base station. So this is antenna. And at the very bottom, there are sectorial antennas and some other radio equipment that would provide this radio communication network. And what is interesting, you see, there is a nest of the birds. The birds made their nets here at our antenna. So the capacity, throughput capacity is 30 gigabit per second, and also this is a guaranteed speed for transferring the data. And you know, here when we speak about vehicle control, the operator would receive information where the equipment or vehicles are located, what operations are being done by these vehicles, the position of different parts of the excavators or the dump trucks. We've chosen very optimal decision, taking into account functionality and the cost. You know, Beeline actually serves for 11 million subscribers, and now in this case we've chosen a specific approach, and here we've chosen the best and the optimum based on the cost equipment. We've also projected and designed a specific fault-free architecture. If one knot or if one part would be faulty, all the other network will be still working. And all our components, I mean the server equipment, the transmission, the commuting parts, all of them are built on topology 1+1. As I have already mentioned, this network is for the system, so that to manage everything, and it was Venka company, and they also put their own requirements, and of course we took into account all these requirements from Venka's side as well, because it is very important for our client. So, you know, we understand that when two companies are doing one project at the same time, this is the opportunity to stabilize the work of two systems at the same time. And the second thing, we save the time. The project, private LTE, was took about half a year, and Venka also took about half a year to do their work. So we work together, and it was our joint team, let's say. So here you can see the comments or the feedback from our customer, from the operational director. Here he expressed his gratitude to us, and of course I would like to say that we are also thankful to our clients for giving us this opportunity to build and to design this valuable solution. And in conclusion, I would like to show you the video that we've took about a week ago. You see interesting weather conditions. We had a quite thick fog, and it was quite different. The day was different weather. Sometimes we didn't see anything within the distance 5 meters, but at some time we had lots of sun. So now this is one day from this the works at this pit, at this quarry, and you can see the work of our engineers over here. So thank you so much for your attention. I took 12 minutes, and if you have any questions, you're welcome to ask them. Dear colleagues, please be brave, ask questions. Are there people from mining industry? Yeah, could you please show that? And who is at the, not at the supplier, but at the mine? Who is from Kazakhstan here? Okay, so we have here our target audience. So if you want to ask me any questions, you can find me at LinkedIn. Or if you want to know more about private networks, so you can find my publications. And there was a conference from September, Telecom Eurasia, and you can find all the information about our solutions in a mining company. So I will be glad to have our conversation further in discussion. So now I would like to give the floor to Sergey Nazaryan. So your report is called Digital Transformation, Increasing Efficiency and Profit in the Mining Business. So please, the floor is yours. Thank you so much. I really like your report, especially the videos that you showed in the very beginning. It is really inspiring. So dear colleagues, I'm glad to see all of you here at this bright event. I am from Eastern Gorn Mining Company. But first I would like to speak about Kazakhstan. This is the first time I am here. I really like the friendliness and openness and kindness of people living here. And in my report I will speak a lot about digitalization. And you know, people say that digitalization is not about people. However, I changed my report and I added this person-friendly attitude to my report, because this is what I have seen here. Yesterday we had the plenary session about the prospects of development of mining industry here in Kazakhstan, and I asked a question about the coal industry. And based on the answers, I understood that my report would complement on yesterday's plenary session, because I will speak about our way of development, and the example would be from our coal industry. And maybe my report will help to solve some of the issues that we can observe in the industry of Kazakhstan. I will speak fast because I want to tell more and I have only 12 minutes, but if you want to talk to me in more detailed way, we are here, booth number 40, so please come to us. So what is Solntsevo coal mine? Over the last 6 years, so we've increased almost 3.4 times, and right now in our plan is to produce 185 million tons. So this is a very big number, and actually we are coming to the large suppliers. So speaking about increasing our volume, I know that we are increasing different indicators, and through our efficiency program and digitalization programs, we reduce our cost for 10%. And you see, we have increased the speed of dump trucks and increased productivity of complexes. You can see it on the screen. Here we are showing briefly our way. This is our way on increasing our efficiency. So we've started initially looking at these production processes, but now we are moving to, let's say, unmanned production. If we're speaking about efficiency, over the last year, we showed the efficiency of all our projects, and EBITDA is 5%, and this is about 5 billion tenge over the last 3 years. So let me briefly speak about each of these phases, but I also would like to say that digital platform is a nuclei of our processes. We always try to reduce the cost and to be efficient. So this is a priority of our company. Digital platform was born, and it was the evolution to support our projects. So speaking about the first stage, so this is a process monitoring. Here we've used template software solutions for industry as ACD query. So here we analyzed different works and checked the performances. We also analyzed the plan for loading, and we tried to ensure dump truck loading, and we were able to reach the number 4 billion. So, we know that we have lots of variations, and the tools that we've used didn't let us to have some flexibility. So when I say variability, what I mean? Let me show you. When I say variativity or variability, it has different factors. So first of all, we have operators. We know that our operators have different motivations, they have different types of work, and we've understood that only 20% of operator, they can perform a standard production volume. Most of them worked at a lower basis, but some of them worked higher. And there are different approaches, different types of vehicles. Even when we have one type of vehicle, we see different indicators. And of course, it means that we have a high potential, and we need to use this potential. We need to reduce, first of all, variation or variability, and then we would receive the high effect. If you see two latest graphs, for example, average technical speed of our BLS equipment, you see how we reduced variability in average. We understood that here we have high potential, because if it is even one route and the same weather conditions, we see the difference in the time and in the duration between different dump trucks. And again, even if we speak about fuel consumptions, we also see different numbers. We started to analyze these numbers, and we started to optimize it, and it led to declining of fuel consumption. So we started to make it in a more systematic way, and we are trying to conduct master shifts. So when a big team would come, all people from repairing department, from energy, from water transport, and we start to manage different indicators. And we understood that our possibility is still limited here. And then we've decided to start our own platform for storing big data. And we are trying to build our own module So we've received the monitor of event monitor that allowed us to generate events based on deviations from process standard and downtime. We saw, we start to understand where we have some congestions from vehicles, like in Yandex Taxi, and at that time we've decided also to. This allowed us to save about 6 million. So the existing system didn't allow us to manage shifts efficiently, and we started to think about some other digital solutions that might be there. And let us now come to the third stage, which is a revolutionary one, when we start thinking about dispatching. And actually, I was abroad. I saw different solutions about dispatching. And what I saw, there are 2 or 3 dispatching specialists, operators. They look and they operate all of these processes.
Не знаю, стандартный путь, и нам он не подходит, потому что мы хотели эволюционного прорыва. Собственно, мы трансформировали диспетчерскую в ситуационно-аналитический центр, в котором сейчас находится порядка 8 человек. У нас там находится начальник смены, находится диспетчер по автотранспорту, горн-диспетчер, находится специалисты по открытым горным работам, которые могут принимать там коренные решения онлайн сразу в смене. У нас там находятся представители дорожного участка на постоянной основе, ремонтники, энергетики. Все ключевые участники, они находятся в одном едином пространстве. То есть это те люди, которые могут оперативно принимать решения, то есть управлять и корректировать смену. И, соответственно, учитывая то, что они находятся в одном цифровом либо локальном пространстве, у них улучшается между ними взаимодействие. В то же время параллельно мы стали использовать уже искусственный интеллект для того, чтобы детектировать операции, собирать большие данные.
We also rely on AI. So now we understand better drivers' fatigue drivers' fatigue because work has increased in productivity. So we have started gathering information on motor failures. As a result, the motor and drive failures have decreased. Where we have started collecting information on bulldozers and other kinds of information. But our problem was the people. So we realized that all this amount of information is not processable by people, in ordinary situation. And we've started working, to develop our own digital platform. And in that digital platform, we started prioritizing machine learning and AI to help machines give prompts. So we started helping the machine remove failures and mistakes. It needs no reprogramming. It has evolved into various modules, and each of them have their own added value. You can see it on the screen. And besides, we're also progressing towards AI introduction. Unmanned production is a matter of the future. It's a reality. We only rely on people for very complex operations. But we rely on AI. AI gives prompts to operators. We've also started outsourcing our logistical centers, first of all, to make it independent of our company because it has a huge potential. Besides, in Russia, for example, there are huge companies like this. And, having a distant information center gives us a lot of added value, and it removes a lot of our headaches and pains. So we are steering towards automated learning, automated teaching, automated learning in the parts of quarry haulers and quarry trucks, making it less time-consuming and more AI-reliant. Some advice just to share with you. Digital transformation is an investment project. It's not a purely IT project. The more data, the better. So having a distant information center is definitely an advantage. People should stop performing routine or standard operations. And of course, you should reach out to each and every one. It should be cross-cutting in your company. Should be cross-cutting in your company. This digital transformation should be cross-cutting, cut across your company. In other words, involve each and every one. Kaz Minerals. I represent the Kaz Minerals company. We're trying to introduce approaches and best practices leading to the so-called unmanned operations. How do you cope with stress and with psychological strain when you try to introduce some new operations? How do you agree? How do you negotiate it with the local authorities? Answer. I always go by the assumption and by the principle. My philosophy is automation is not about laying off people. It's not about layoffs. There are a lot of events, routine events. People cannot handle it in a routine way. It's handled routinely by machines, but of course, people are always out there. What about doing things 100% by AI? There are only individual examples and individual cases of cross-cutting automation 100%. Well, I'm sorry to cut in, but I have loads of questions. Cool, excellent. We're really inspired. Alexei Shmonov, parametric modeling and mining modeling and projections design. Sorry. I'd like to share with you some info on our best practices to mining scheduling on the basis of mining data and the sub-parameters of individual data of individual deposits. Our company has an impressive track record in automating mining activities and introducing SURPAC systems like SURPAC, Manchur, and Whittle. I personally have been involved in over 20 projects, and we have client requests to introduce more automation just to relieve people, to enable people, to help people focus, to shift their focus on the things and the chores and the things they cannot tackle nowadays, because BCG, according to BCG, the BCG company, mining automation isn't really catching up with adjacent industries like machine building, construction, shipbuilding, and all. Our company is a flagship in automating these areas, and we've decided to rely on our expertise and our technologies to promote mining digitalization and to produce new products and items, relying on those products which are already, parametering. What is parameter-based design? Just to give you a rough idea of what it's all about, let's delve into machine building. Initially, things were done on paper. These drawings, people used to draw on paper. There are huge agencies, individual drawings were created. Then they were merged together. Then individual units of a machine or a car were created. Then they used some mock-ups. Again, those mock-ups would often not match together, and they had to do a lot of redesigning. Then the CAT systems arrived, and they started digitalizing drawings on paper, but essentially that was like on paper, paper-based work, essentially, because they had to do a lot of matching up, but the parameter-based technology produced a revolution. Every car has cogs, every car has wheels and cogs, and every time there is a change in one parameter, it has an impact on all the others. For example, we have to calculate, how one item is attached to another. There are parameters like the diameter, for example, the diameter of a fastening element and the thickness. So if we need a bolt and it's not thick enough to latch one item onto another, so if it's not thick enough, we'll have to change the diameter, a whole diameter. So if we do it manually, we'll have to modify all the parameters manually. If we do it using new technologies, a change in one parameter changes the model as a total. Take a look at the screen. We didn't draw this item on paper. It was kind of calculated. It was drawn, but using parameters like the diameter, the thickness, the width, and all. So we can alter the parameters, and the rest of the other parameters change automatically, including other things. Here we have to design a road, and we have to cut it. There are like radii, and the curvature angles. So the slant, we have to factor in the slant. So we have to give some thought to whether or not we should build tunnels. So where we should cut and where we should cut and fill, the cut and fill approach. So all of this, we have to tie in all of these parameters, including the tunnel. So we have to indicate the width, like the length, the width, the angles of the road and the tunnel. Say we have to change the width of the road. Then we change the width. Then the tunnel will be redesigned itself. The amount of rock we have to remove is recalculated automatically. And all of this, it's due to the fact that we have typed in the parameters that have an impact on other design criteria. Speaking of a bridge, so we change the width, the distance between the piles, then the hull of the bridge changes. Talking back to where we have left off, in the past they used to produce drawings on paper. And it's something companies keep doing. Later on, we saw the advent of the CAD system. It's 2- or 3-dimensional drawing with some parameterization criteria. But there was some systems. They didn't make things dependent, like the width of an axis didn't automatically impact on the whole of the model. What is the problem with the conventional design approach? All of the entry parameters, if they change, they will require that the whole of the process be changed. For example, there is an extra well. Then if there is an extra well, then we'll have to redesign the mining activities and the way we view the rock. So it's a problem. Say there is one engineer, he or she changes his or her parts of the model, and another engineer does the same, but for his or her parts of the model. Hence problems, hence issues. Hence, the project isn't optimal. At this time being, the Dassault Systems company is doing work to produce a line of products that concerns the whole of the lifetime of products used in mining. And the key message is, so if we change whatever parameters, say extra wells, extra, say we have new ideas of the tectonic profile, or the completion works, the completion state, whatever this stage, we change the parameters, whatever this stage, the whole of the model changes, the whole of the design changes. Well, I'm referring to not just a project you should defend, you have to promote with government officials, but I'm referring to the designs you use in your everyday work. And with this approach, we no longer have to do routine stuff, and we do what we do. We just don't do it just purely on our own, but with our clients. For example, we have a project, a pit ready for mining. We change the width of a road, then the quarry axis of the road changes automatically, and as a result, the entry parameters are changed, are updated automatically and very fast. Hence, fewer human errors. Hence, higher performance. Hence, time cuts. We could use for highly intellectual tasks and not just for some mundane work. So we have wells, geological wells, so we use them to build a geological model. Besides, we also have a tectonic model, and we also see the cracks, and we show how those cracks impact the morphology of the rock morphology. So, and then we automatically build a model using all of these, factoring in all of the factors, the shifts and whatever. Say we change a parameter, for example, the shift amplitude. The model, the health of the model changes automatically. Of course, we keep a record of the history. We could look, say, 1 or 2 months back into the past and say what our model looked like 1 month or 2 months ago. So concerning the height, say, if we add 1 or 2 stories, 1 or 2 levels, then everything changes again. I'm sorry, the speaker apologizes. If you have questions, please fire your questions as long as we are within our time slot. Thank you. Please fire your questions in English, Russian, whatever. Do you think? Could you share with us? Could you illustrate it? Illustrate your point. I mean, how using this new approach has resulted in money cuts. We're only testing the system out. We're implementing our conventional solutions. We're still implementing conventional solutions. I can't give you any implementation illustration, any case. Speaking of using parameters in mining, the so-called parametrization, we have managed to increase the NPV by a matter of several million. So our calculations show that it's something we can achieve. Thank you very much. Unfortunately, we have run out of our time. We've gone beyond our time slot. Pavel, please. Business changes as a basis for a digital transformation. Well, we are talking about steering and changing business processes. We are like advisors, we act as advisors, and what's very pleasant and very crucial to us is the fact that the key messages in this presentation They are highly in line, they're very in line with what our previous speakers have been exposed to. Before we address our topic and before we really delve into the business processes, I would like to present our company is a global company, Step Change Global. It was founded in 2008. It has a narrow focus, mining, petrochemicals, gas, and it's focused on pretty narrow services, a narrow range of services. I'm referring to digital transformation, and what we do is to assist in introducing digital transformation, introducing models on the basis of deep integration. We also help conduct the digital analysis of a company's digital maturity. In other words, the IT penetration and its level work from the standpoint of best international experience. Let me start on, by using a non-academic definition of what digital transformation is. You can see it on screen. We are deeply concerned, but we deeply believe it's about data measurement, and it includes deep digital integration and data integration. It's done by a special team. This team is comprised of multidisciplinary experts, and those experts can help you see the impact, the introduction of a solution on the whole supply chain. And data are handled in real time or almost in the real time mode. First of all, I would like to address the organization aspect of digital transformation. So the so-called integrated operations centers play a major role here, or the so-called situation analysis centers. What is the key difference of these centers from the so-called dispatcher or scheduling or dispatcherization agencies and services? Well, integrated operation centers are not only about data flows, but they are really about rendering fully fledged engineering support, in a one-stop shop mode. Of course, providing that there are experts and there are mandates for decision making. But on the other hand, integrated operation centers, they are a so-called an open window for the conventional divisions, because it is in that place that you can get a very good idea of what's going on at the where the mining activities are being performed. Integrated operation centers can work, should be focused to address specific headaches or pains or concerns, but our experience shows that what a main priority is the engineering matters, engineering aspects, and like such as accompanying mining activities, and things like things capable of bringing added value if you use things in a cross-functional mode. So what would it look like in real life? Take a look at this slide. You can see a chart, a flow chart. It describes all of the processes or mining activities are comprised of, choosing the right strategy on maintenance, the actual maintenance activities, cost and benefit calculations and all. The largest benefit falls to the processes which enable us to work in the operational mode, activity mode. Here you can see a real project on the screen where part of the responsibility for doing these processes, starting from monthly planning and ending into some calculations, was being made part of the operation integration centers. We also perform like the detailed design of these processes. We identify the functional substance, which again generates the logic, the philosophy, the entry points, the exit points. We also identify the labor intensity of each of the functions and steps and the role they play, and the role delineation. Why? Roles, if you have a very good idea of the roles and responsibilities, every division is assigned to a role and a responsibility within the system, then as a result we'll have a very systemic approach. So there will be a very good delineation of responsibilities between integrated operation centers and the mining, the activities in the headquarters in the mining location. So hence no redundancy, no function duplication, no so-called blind spots where there is no responsibility, there is no assigning of responsibility. Again, functional responsibilities are very clear cut. Again, we can all merge it into a clear-cut job description. And again, all of these functions are assessed for its labor intensity and regularity, which enables us to have a very good idea of our expert's working schedule, whether or not he or she can, he exists or she exists in the routine operation mode, and they cannot really look ahead and look forward. So if the share of these routine operations is very high, say, for example, these routine operations are of major concern, when we are talking about very high qualified engineers, then we run another cycle of detailing. We analyze a function by the functions they do manually, by the functions they perform on a computer, say, then we have a better idea of the needs, of to what extent we should and we need to develop these systems, and we have a very good idea of how oscillations in the workload for each of that of that expert will have an impact on business operations. I'd like to share with you info on a business project. We have done our work for the tech company. We have run a complete work on the design. Its company is located in Santiago, Chile, and where they run a pit. This screen shows all of the complete process analysis. We have analyzed the processes. We've analyzed the processes which we could integrate, we could shift, like energy, things, some other things, and we have assigned specialists and experts. And all of that groupings of experts, it was defined by our concept of work efficiency and of their work efficiency. Some key takeaways we have been exposed to in our work. There are two of them. The first one, integrated operation centers should be designed and run depending on the specific concerns and headaches within a company. And secondly, I'd like to build on the statement made by our colleagues. They said digital transformation is not about technologies, but it's about a cross-cutting transformation of their working activities on the basis of modern technologies. Thank you.
Any questions from our audience? Please, please, I see lots of questions, so thank you for your activity. Okay, no. Let me ask the questions then. So could you tell me, please, how we can calculate, if I am the customer, how I would calculate the investment return, rate on return, ROI? Well, we can answer quickly. We have the full library and data on this. I cannot give you the specific numbers, but usually we've created the centers, and then 6 months would be for BHP Wellington. We did this project in Australia. There we had 3 months. And what was the investment volume? Millions or 10 millions? Well, it depends on the specificity. And again, speaking of BHP, it was about $10 million. Yes, these are the numbers that we cannot believe. 3-6 months, this is a payback period. I will be happy to discuss this with you. Thank you. Thank you so much. We are good about the time. Our next report is by the following speaker. We have Nikolai, who will speak about the optimization of mining and processing plant productivity using advanced control systems. So thank you so much. Good day. Hello, dear participants of the forum. Well, my presentation is dedicated to the improving control or advanced control systems. So we will speak about digital transformation because, the digital transformation of enterprises became the driver for implementation of such kind of projects. I will briefly touch on the reasons why APC, Advanced Process Solution, becomes the driver of digital transformation, what results we can achieve due to these advanced process control systems. Well, first of all, we need to understand where these APS systems are located in different levels of optimizations and automatization. So here you can see the standard EC from 1995, where the basis of this pyramid is the technological process, the main process equipment. Then if we go higher level, we have different measuring devices, analyzers, and then control systems. Then the third level is automated system of management of this process, technological process, and in 99% of cases, this used some specific types of regulators. Then the next level is our APC, Advanced Process Control, which has more integrated sub-levels. Here we speak about automatization, a specific chain of operations. And then the level higher, it would be fifth and sixth level. These are the solutions that are responsible for digital transformation of the enterprises in general. So speaking about digital transformation, we need to note here that our market has different types of solutions, lots of opinions on how these solutions shall be implemented. But most of these solutions, they are about some simple things. So first of all, what we are trying to understand. What is happening with our processes? Why it is happening? These are the questions that we're trying to answer. So, and actually these types of questions are asked at each enterprise. But from the digital point, we want to look further to the future. Our task is to understand what will happen with this technological process and how to manage this process so that to receive some forecasted indicators. And in this hierarchy, in the industry development, we can say that so that to go to the next level, next step or stage, we have to have more data that we would receive from some physical subjects, from some sensors. And of course, here we speak about some digital resources where we took data from physical subjects and then through some additional calculations, we are forming a big number of digital data. In Western culture, such solutions are called software sensors. And thanks to this, we understand what will be happening at each of the flow, at each of the operation stage, and we understand how this operation and process works. And it enables us to forecast, to predict where this technological process would go. And if we have a well-built automation levels, we will be able to achieve our predicted indicators. Why APC becomes more and more important, especially now during digital transformation? Yes, digital transformation allows us to forecast. However, to make the process forecasted and predicted from the management point of view, we need to have higher level of automation. And this is a driver for the development of such types of solutions. So to speak about it, here, let's say this is a roadmap on digital transformation of one of our customers. And this is just the beginning of roadmap. However, at the very beginning, we do have this additional equipment on automation process, and then after we have the implementation of different APC solutions. So we are trying to additionally build all the necessary elements for automation so that it would allow us to enable all the opportunities to implement digital solutions in full extent. So it's not only about prediction, but also about management with the specific forecast or prediction on some of the indicators. MET's company has its own advantages, and our benefits and advantages are the following ones. So we are dealing with the development of processes, supply of main process equipment, additional equipment, auxiliary equipment. Besides, we also have the department of automation processes, and this department has a big number of proprietary products that would be aimed at automatization. So we have different samplers, analyzers, some measuring devices, advanced measuring devices, and of course our digital solution started from APC and up to technological or process twin, digital twin. Then we work up to hydro mining industry. So we can cover the full value chain if we speak about this mining area. Speaking specifically about APC solutions, I can say that we do have a number of solutions that are aimed at process stabilization, and usually such types of solutions are focused on the most difficult from management point of view processes. When we speak about process of grinding, process of flotation, we also have a number of optimizers that allow us to optimize all technological processes, starting from the preparation of the work and finishing with the release of ready-made products. What it means, stabilization and optimization. You know, when we have the basic process, here we have PID regulators, and of course it is non-stable. And what we want to do, we want to stabilize this process. However, if the process is stable, it doesn't mean that it shows full efficiency. So that to increase this efficiency, we are doing optimization. First of all, we make the processes stabilized, and then this allows us to make optimization of processes and to increase the equipment efficiency. And our customer, in fact, receives higher technological indicators, financial indicators, without any additional financial inflows. Let me brief you on architecture. Our solution is being implemented on a separate server that has been integrated with customer's infrastructure, and our server is actually located at customer infrastructure. However, we have there our proprietary software that has a library of different solutions connected with APC, and this allows us to increase the deployment process. And we are using some templates And when we use templates, we need to do the calibration of the system. We do not write the code from the scratch to the existing system of control and management. The second advantage that we can mention is that we can also provide remote support to our infrastructure without having access to the customer system. So all the issues connected with safety, they are all in compliance. And the third aspect, when we speak about such type of architecture, is that such systems allow us to expand the functionality of APC solutions, and we can do it quite fast because we are located in one development environment with lots of presets. And again, it doesn't matter which specialist provides this support. Anyway, these specialists know all the software, knows our approaches. And in conclusion, I would like to share our experience. This is the implementation of APC solutions of one of our customers during 12 years. This is a program including different implemented programs, and this all started with APC integration for our mills. Then we did the optimization of grinding, then primary grinding, then flotation. So we did and thickening process. So, and actually our customer was able to observe the increase of productivity, increase of different indicators. If we speak about flotation, here we speak about the increase in extraction of valuable components. Then, of course, we speak about process stabilization. If we speak about the density of thickened product, the percentage. And, of course, here we speak about the increase of extraction of clean water to the process. So, but during pandemic, we also have the specific architecture. This is a system of enterprise automation, and it allows, we can do it remotely. So during pandemic, we were able to do it. So, and APC systems worked in 95% of time during the latest 5 years. And these indicators are very important, and our customer is interested to work with us. So with this, let me finish my presentation. I want to thank you for your attention, and I will be happy to answer any questions you might have. Thank you. Dear colleagues, are there any questions? My name is Irina Shvets. I have a question. Here you mentioned optimization of the crushing system using some IT. Could you please speak louder? Okay. Could you please tell us what tools did you use to optimize the crushing process? Well, if we speak about crushing process, the most important here is to preserve the size of this crushing. So we monitor the size at the feeding part, and then we also monitor the part of this crushing at the exit, at the output. So we check if this drilling and explosive works are done quite correctly, and if needed, we also manage our crushing machine. If we have the right to regulate the size, we can do it. But speaking about crushing processes, this is one of the simple processes of optimization. Okay, any other questions, dear colleagues? So for those who will be watching this recording later, could you tell us 2 or 3 key reasons for the customer to whom you propose your systems for implementation? 2 or 3 reasons why your systems shall be used by the customers. Well, actually, I guess I mentioned it during my presentation. Well, first of all, the main reason is to increase the productivity or efficiency of the enterprise. And I think it's actually difficult to find any other reason for rational. So when we increase the productivity, we increase the level of quality with regard to content, with regard to moisture, and this is one of the main drivers in using our optimization solutions. But how do you prove to a client that this is the tested and approved indicators? Well, most of these solutions have already been existing for 20, 30 years, and there are lots of scientific articles published with our solutions, how these solutions can increase the productivity. So we are using the heritage of those projects that we had in past, and we are giving the information to our customers what could be expected from this solution implementation. For example, increase from 1 to 3% of productivity. And we know that after 50 projects that have been implemented in the crushing area, this is the numbers, and we tell about it to our customers. Of course, to calculate the exact number in some specific cases is difficult, and actually it's impossible because there are lots of specificities, lots of different things. However, we can give a range of predicted indicators, and this is possible. Thank you so much, Nikolai. Thank you for this interesting report. Our next speaker, Ekaterina, please, the floor is yours. So here we are speaking about managing of mining and exploration projects. Hello, dear colleagues. I represent AGR software company. In Russia, we have the richest experience in making the system of storage of data. And we have the office in Kazakhstan, where I am myself the general director, and we will be happy to talk to you. We'll be happy to have a fruitful cooperation with you. And after this session, I would like to invite everybody to our exhibition stand, and there I can tell you more details about our abilities, about our products, and we hope for cooperation. Today we have a very interesting session, and to be honest, I'm really happy that Beeline is a moderator of it, because I want here to focus on the fact that modern systems require the specific technical and infrastructure software, infrastructure solutions. And right now, of course, we need to use sustainable communication channels so that to have maximum efficiency from the use of our products. And as any other developing company, we are based on the needs of the market, on some technical conditions. And if we move to the year 2010, when we released our first system, at that time our main task was to provide fast digital documentation for our mining specialists and geological specialists at some field works where there was no network coverage at all. And based on this, our product meant work without any network. We did different automated calculations. We prepared different documentations in automated form. And actually, we've made all the routine work of the geological specialist into automated processes. Now, of course, everything has been developed. The needs of the market has been changed, and other different conditions are changing. And we see that right now the increase on operative control in the real time is increased. And of course, we developed our project as well. Nowadays, our AGR system covers lots of tasks and has lots of functions. I'm not going to speak about it more because mainly now I want to show you the financial effect from using the specific software from the beginning of the design. So right now we are digitalizing everything, starting from data collection up to the managing of the system. And our system might be integrated with different types of equipment, with other external systems, so that to reach maximum results. Of course, by developing our technologies and by solving different tasks, we mainly focus on trends, on requests from our customers. And when we develop our solutions, we try to follow modern approach because the main result is what? to have information that would gives us opportunity to analyze everything and to take some lessons and to process this information again after analyzing. Now let me go to the description or to the main topic of my report. We have actually implemented into the projects in Yakutia some of the solutions. AGR software is a part of a group company that is dealing with IT consulting, and we also our partners have their own parts or subsoil parts, and they're preparing the deposit before the exploration.
So here we can see two areas or territories in the Russian Republic of Yakutia. A lot of challenges, permafrost, very short summers. We did perform the key prospecting activities, drilling, geochemical surveys. Does anyone know how we can run a video? Work at the work design in planning stages. We used not only the AGR information system, but we also relied on the Microsoft Office to digitalize matrix data, in our at the design stage. The planned and the historic data were already uploaded. Where in the GIS system, information had already been processed in the GIS system. Besides, we have at the initial stage, we customized the whole of the information, giving the geologists a very good idea of the quarry, of the pit, and all of the deposits to enable them, to help them work with digital work. We monitored these territories in an online mode. We did some satellite surveying, and our colleagues had an opportunity to share information, exchange information with our head office. Things were done to monitor our works, and of course there was a very good opportunity to visualize the results, just to give people an idea whether or not they've cut into the ore rock containing bearing rock or not. Again, in 4-day modeling, again they had an opportunity just to model things and simulate things. Reports were generated in an automatic mode. No extra software was utilized. The key outcomes. Here are the key outcomes. Well, we previously had compared the work of our partners at these territories. So the technical conditions were the initial technical conditions. The number of hardware was equal, like it was an even playing field. And with the technologies being an equal playing field, these are the results and the outcomes. What I have framed, what you can see framed on screen, is the work done by our partners who had been introducing the AGR information system at the design stage. So what do we see? What are the key takeaways? Over a shorter period of time, we managed to obtain more information on drilling, more data on mining, like on various routes and survey routes and all. So the money was like the same or less money we paid, but the amount of work we did was higher. There was a higher amount of work. There was more work we managed to do using the same money. This shows, the results of introducing software where we see substantially high benefits through better decision making, through process automation, through faster information data exchange, through cutting down on personnel on personnel on site and shifting people to other places. We are introducing cutting-edge systems, and this, of course, offers substantial benefits. So we have identified these numbers, these data. The productivity saw a 20% rise. Data processing rose by 60%. And the expenditures were only 1/100th of those on the market in general. So we calculated how our partners, our competitors, had spent on drilling, for example. Why drilling? This is the figure we can show online. We can find this figure and compare. So at our projects, the average drilling costs for 1 square meter was 5,600 something rubles. In 2022 and 2024, why were the numbers higher? We had to purchase the hardware. So we purchased the drilling hardware in 2020, 2024. So, if we draw a comparison of these costs, like in prices on the Russian market, the average drilling costs for 1 square meter is 20 to 28,000 rubles. So we can say with good reason we implement these modern cutting-edge digital tools, and then the offers we can see are quite obvious in terms of productivity, in terms of cost cuts and other things, just to get the maximum value on new digital tools. We need also the so-called technical and infrastructural assistance. The financial benefits are not necessarily obvious at the initial stages, particularly when we are not doing this. If we're not doing this at the initial stage, it takes time, and it takes systemic approach. We have to do things systemically, and as a result, we give a boost to all of the processes, and again, hence we can optimize, we can plan things ahead, and again, and the economic benefits speak themselves. Thank you, Katerina. Dear colleagues, do you have questions? It looks like there are not so many questions. There aren't so many questions from the other part of the audience. Let me just fire one. There are data, there are technologies, there is good assessment or expertise, so to speak. There are good competencies. But I, as a moderator, simply must ask a question about AI, artificial intelligence. There is going to be an IM forum. We are going to talk about artificial intelligence with our US video client partner. My question is, where are you moving in terms of artificial intelligence? Answer: we are trying to keep up. We are trying to stay current in terms of modern trends. But, in the field of geology, it's merely a trend. Well, our data have been processed and codes have been have already been assigned. We have already aggregated these data as data sets into data sets. We are trying to steer towards using algorithms, and algorithms are something we are already utilizing in our everyday day-to-day activities. Speaking of assessing pictures, snapshots, there is not a single company I know of, anyone capable of using this snapshot analysis technique in geology. Just look at the snapshot, and you have like your moment of enlightenment. Because not even every human being or expert can identify, the type of mineral. Counting cracks is okay. Spotting some things is okay. But having a machine, a machine capable of counting and identifying like the the mineral types for you, is something which is a matter of the future. Well, I'd be happy to hear Elon Musk or some other prominent figures on this matter. Do you have, ChatGPT? If you have any experience in using this artificial intelligence in analyzing your snapshots and your visual information? I would invite all those of you willing to do this I would invite you to our session in June. We might say here something at other tax sessions. So it will be really a very at the very forefront. This topic will be at the very forefront. Deepo Singh, I have the future of mining in 4.0 drone solutions on the basis of artificial intelligence. Yes, please.
I'll be giving my presentation in English today, so please bear with me. I'll be slow so that I can communicate well with you. We are an organization called Aereo. We operate out of India. This is the first time we are visiting Kazakhstan with the intention to collaborate and expand our presence here. So we are a very different organization, and as previous sessions were being discussed around a lot of digitalization, so we help organizations digitalize their topographic data using drones and then extract very specific business intelligence from the data set. And as we were discussing about uses of AI for visual interpretation, this is exactly what we do. So if we talk about drones, they are becoming a modern tool for surveying in most of the mines, but the data is being used mostly for only topographic survey techniques. And the utilization of data for further downstream impact is very limited. Reason being is that these data sets are very large. It's very difficult to centralize and integrate these data sets with rest of the geological and GIS information. And it requires dependency on a lot of different softwares and skill set to make use of this data for various benefits. So as a result, what happens is the data is generally not available to everyone. So as an organization, what we do is we take this data into our very specific solution called Aereo Cloud. We process this data, analyze this data, and generate very specific insights on the topographical information, which are further used for taking day-to-day decisions in the mining enterprise. And we also make sure that the data is available and accessible to almost everyone in the organization with a click of a button. So just talking a little bit about our credentials from what we have been able to do in India. So far we have conducted more than 750 mine surveys across different mines in India. There have been more than 1,200 stockyard surveys for volumetric estimation, space optimization, and more than 30 large mines have been digitized using our solution. So mining is just one portfolio of ours. We also work across different use cases. So we have mapped close to 50 large cities in India using drones and helped the generation of 3D twins of these cities and also certain business intelligence over it. In terms of the scale of work, in a single geography, we have mapped around 28,000 square kilometers, which is a large province in India, and help them generate a fresh digital land records. And most of the large mining companies in India, which are operating in different domains, are using our solution for regular business decisions. So some of these use cases exist in coal production, where the world's largest coal producer, called the Coal India Limited, has digitized 7 of their mines and have seen more than 60% improvement in their production with the help of the insights which we provided. And one of the largest steel producer in the country, called the Tata Steel, all their mines and stockyards currently are using our solution, and they are doing their data updates at, let's say, 15 days intervals, and taking decisions based on that, and they're revising their production and schedules every 15 days interval with the help of the insights which we provide. So what we have done, we have tried to cover the entire value chain of the mining ecosystem. So we have delivered use cases across the entire life cycle of the mine using the drone data sets. And the cloud solution, the Aereo cloud solution, has tools to make sure that you can use it at different levels in your mining operations, including your day-to-day mining operations. So as I was talking about earlier, when it comes to uses of drone data for various business intelligence, it requires a lot of investment into different softwares, different hardwares, and still the access of the data is very limited to few people who are having expertise in handling that data. So that reduces the impact of the data on the enterprise. It doesn't help the top management. It can only help a few handful of surveyors in the mine to take their decision. So we just made sure that with the help of analytics we deliver, we can deliver the value across the value chain, from the head of the business to down to the level of supervisor on the site. So in case of Aereo Cloud, there are 3 major elements. One is, how do you process large scale data at quick turnaround time? And then when you process all of the data, how do you ensure that all the GIS operations and geological models can be integrated at one place and available over the cloud with low dependency on internet? And how do you also run AI-based solutions on these data sets so that the accuracy and the consistency of the output can be replicated at scale? So this is what Aereo Cloud does. It generates 3D twin of the mine like any other software available nowadays, but then over and above that, we run very specific analytical solutions to extract some very specific reports. So these are some of the outputs which we are able to provide. If you're doing periodic survey of your mine using drones, we help do change detection. We also help do very specific volumetric changes on different locations. We help you generate understanding of the slopes in different parts of the mine, and also analyze the condition of your safety compliances, environmental compliances, haul road health assessment, and also integration of various GIS layers which are required at different, let's say, time interval in a mining operation. So while this has all been done, we have also made sure that the solution is very enterprise friendly. So the data security, safety, as well as the integration with other software has been ensured through very specific engineering tools which are available in the platform. And with the help of APIs, we have been able to integrate the data sets with other mining software so that you can consume our data into the conventional mine planning and scheduling software, as well as you can integrate the data generated from these mine planning scheduling software back into our platform. So we have just started doing a very specific partnership with DataMine, where through automated APIs, the data will be accessible across the platforms once it is available on our platform. So 2 case studies quickly to cover. So talking about one of the largest steel producers in India, Tata Steel Limited, they have 12 open cast projects of different minerals. So they are using our solution across 12 open cast projects and 60 different stockyards. And every month, the data gets revised using our solution and pushed on the cloud. And they have seen almost 99% accuracy in their volumetric estimates. So entire corporate audit team in Tata Steel uses our solution. And we have increased their speed of data collection by 25 times and improved the number of efficient decisions which they are able to take by almost 10 times. Another example of Coal India Limited, it's a huge organization with almost 85 open cast projects. So far, they have gone to phase 1, where they are implementing this to 7 largest mines. Each of these open cast projects are approximately 4,000 hectares in size. That's the size of the pit which they are operating today. So in the last 1 year, we have mapped about 1,300 square kilometers of area collectively for them using drones. And they have conducted more than 400 drone surveys across these projects. And more than 200 users in just 7 mines across the value chain are currently actively using our solution, and they have generated more than 2,500 different reports, which they used to generate across different consultants earlier and still were not able to correlate the data sets. So quickly giving you a demonstration on how the platform looks like and what all it can do. So it's a cloud platform. All you need is a browser, login. All the data sets which you collect from any of the drones which you use currently, you can push it. The data gets processed and it is available as one of the iterations. So you can have multiple iterations stored in the same place. So once the 3D twin of the mine is developed, there are a lot of other information which are basically extracted. So you can run this platform on your mobile internet as well. So it doesn't depend on high bandwidth internet. So one of the reasons for that is to make sure that it is available in the remotest of locations. Then with the help of AI tool, we can read various features of the mine. In this case, we are reading the bench features, bench toe and crest, and the break lines. The contour maps are generated using the data sets and your parameters. And once these basic data sets are generated, then specific visualization and analytical solutions are extracted. In this case, there is a topographic plan which is integrated to the same data. Your drill information is integrated to the same data. So you get better contextualization of how your mine currently exists, where it is deviating, how is it progressing. And with respect to exploration activities, we can map the area of interest, integrate various geological information, the outcrops, orientation of the structures which are present, again using purely image processing. And then once this is done, you can integrate your mine plans with your mines and see how well the mine is progressing with respect to the plan. So you can do deviation analysis as well over a period of time, and you can help your production to catch up with the plans which were developed. So you can pull in the data from different sources, some softwares like DataMine, and you can put it into one place. So with respect to the production activity in the mine, we have various analysis which is being done with respect to the change detection. So you can detect the active areas based on where the changes have happened with respect to the previous interval. You can then do very specific volumetric estimates. You can also identify places where dumping has been done. Again, you don't need to put any manual activity into this. Just click a button and the software will detect where changes have happened and what was the volume of those changes. So we have certain specific solutions with respect to mine safety as well. In this case, we are detecting the width of the haul road at different sections. And you can identify the points where the width is lesser than the standard, then the gradient of the haul road. As you can see, there are sections which are having higher gradient, leading to safety issues, higher fuel consumption, and also reduction in the time. You can do slope analysis, customize your ranges, and see which are the sections which you want to focus on, and take preventive and corrective actions. And you can generate elevation profiles over different time intervals to see how your mine has progressed with respect to the plan, or how far it is from accessing the ore.
I'm sorry for interrupting you, but your time is out.
Yeah, this is done.
Thank you so much.
Questions, please?
Уважаемая аудитория, может быть, есть вопросы?
Dear audience, are there any questions to our speaker? So yes, please. My name is Irina. You were showing the lines that are the elements of the mining graphics. Could you tell us, are they modeled by hand, or are they modeled automatically? Some graphic lines.
You have to define your parameters, and then the model can extract those details.
Еще вопросы есть, пожалуйста, коллеги?
Any other questions, dear colleagues, please? So if there are no questions,